Hello everyone, welcome to Kashiano Easy Math. We have here three equal size tangent circles such that they enclose an area of 2 square units. And in this video, we're going to solve for the radius of the three identical circles which are tangent to each other. And so, how do we solve for the radius of these identical circles? So then, since an area is given, the central area enclosing by these three the same size circles, that is 2 units. So this implies that we're going to express radius in terms of area. So we can solve for the radius of these circles. And so how do we express the radius of the circle in terms of its area? So now we start labeling the centers of these circles. So we'll label this as point A, and here B, C. So next, we're going to connect the centers of these three circles. And so we now have the centers of the circles connected, and we have formed an equilateral triangle. And so now, based on our figure, the equilateral triangle has sides of 2r, right? Since this line from the center to the point of tangency, that is r. Same way on here, the same way on here, since these are all the same size. And so now we can isolate the equilateral triangle ABC. So now we have here the isolated equilateral triangle ABC, and the sides are 2r. So we have here all the sides are the same. So this is 2r. And this here we have 2 square units. And so from here, based on our figure, we can now express the radius of the circle in terms of the area of the sector of the circle, then equating to the area of the three sectors in addition to the central area enclosed by these three sectors. So we'll be forming our equation based on our figure. So we're going to have area of the equilateral triangle equal to the area of the three sectors plus the area enclosed in the middle, that is 2 square units. So alright, so let's start solving. So first we're going to solve the area of the equilateral triangle. But first we have to form our equation. So that is from the areas. So area, let's say area of the equilateral triangle is equal to area of the three sectors. So area 3s, 3 sectors, plus the area enclosed, that is 2 square units. And so from here, from this equation, we can express the radius in terms of the area, and area of the three sectors, 3s of 3 sectors, is expressed in terms of r. So now let's solve for the area of the equilateral triangle. From the formula of the area of a triangle, that is area of the triangle is equal to 1/2 base times height. And we have here the base is 2r, and the height, we don't know the height. So we're going to derive the height from the figure. If we take the half of the equilateral triangle and consider the right side half of the triangle, we have AC, and we call this point D over here. So we have D and C, and the base is half of this, the base of the equilateral triangle. So that must be R. And the height, we have here the height, and the hypotenuse, that is 2R. Since we need the height of the triangle now, we have to express the height in terms of the radius in terms of R. So we're using the Pythagorean theorem to solve for the height of this triangle ACD. From the formula, c squared is equals a squared plus b squared. We designate the base, that's CD, so this is the base, and h as the height, or a in here. So we have c squared, where c is the hypotenuse, by the way. So we have 2r is squared, and a squared is height, so that is height squared, plus b squared as the base. B squared is r squared. So we have height squared is equal to 2r squared, so that's 4r squared minus r squared. Solving for the height is the square root of 4r squared minus r squared, that is 3r squared. So we have here the height is equal to r square root of 3, or that is equal to square root of 3 times r. Solving for the area of the equilateral triangle from this formula, we have here now area of the equilateral triangle is equal to 1/2. The base is 2r, if you remember, since half of the base of the equilateral triangle over here is r, so the base is 2r. We're considering the equilateral triangle. From here we have 2r as the base, so we have here 2r times height, where height is square root of 3 times r. So here we have the area canceling 2 right there, that is square root of 3 r times r, that is r squared. And this kind of derivation, that's where the area of an equilateral triangle is derived from the formula. A is equal to square root of 3 over 4 times the square of the sides, and all the sides are equal for equilateral triangle. And here in our case, the side is expressed in terms of the radius, right? So if we express the side of the equilateral triangle in terms of r, we have here the side of the equilateral triangle is equal to 2 times r, right? So 2r. So we're expressing here the side as s. So r here is equal to s divided by 2, right? And if we substitute this value of r to our equation, area of the equilateral triangle, we have area is equal to square root of 3 times r squared, where r squared is s over 2 squared. So we ended up with a square root of 3s squared and 2 squared on the denominator, so that is 4. So that is square root of 3 over 4 times the square of the sides. So we have this formula. So back to our computation of area. So we have the area of the equilateral triangle in terms of the radius of the sector, or the radius of the circle. Next is we find the area of the sector. So the area of the sector is derived from the area of the circle. Suppose we have a figure over here, and this is circle. So we have here a sector is just part of the whole circle. So we consider this angle, say alpha. So we have here area of a whole circle, that is pi radius squared, and that is the angle, the central angle of the whole circle, that is 360 degrees. And this is compared to area of this sector right here, that is area over the subtended angle of the central angle, so that is angle alpha. So we have here area is equal to pi r squared times alpha over 360 degrees. And back to our figure, we need to determine the value of angle alpha to find the area of the sector. Since we have here an equilateral triangle, that means the angle, we have the 3 angles over here, that is 180, the total of all these 3 angles. So that means each angle right here is 60 degrees. So from the formula of finding the internal angles of polygons, we have n minus 2 times 180 degrees is equal to the sum of all interior angles. Since we have equilateral triangle, so we have 3 sides. N is 3, so that is 3 minus 2 times 180 degrees. So 3 minus 2 is 1, times 180, that's 180 degrees. So we have here the sum of interior angles. So since that is an equilateral triangle, they had 3 equal angles, interior angles. So we have 180 divided by 3 angles. That comes up to 60 degrees. It's all equal angles. And so back to our formula of area of the sector. So we have here, so substitute the angle 60 degrees to our alpha, angle alpha right there. Since we have 3 sectors, that means we multiply the area by 3, right? So we have here now, area of the 3 sectors, 3s, is equal to 3 times this. So 3 times pi r squared, and alpha is 60 degrees divided by 360. So we have here 60 divided by 360, that is 6, and 3 over 6, that is 1/2. So we ended up with pi r squared over 2. So we have the area of the 3 sectors, 3s, is equal to pi r squared over 2. And so now we can go back to our equation and solve for the radius of the circle. It's from our equation over here. Area of the equilateral triangle is equal to area of the 3 sectors plus the area enclosed in the middle, that is 2 square units. And so we have here the area of the equilateral triangle as square root of 3 times square root of the radius. So we have here square root of 3 times r squared is equal to area of the 3 sectors, that is pi r squared over 2 plus the enclosed area, that is 2 square units. Now simplifying our equation, multiply by 2, and so we have 2 times square root of 3 r squared equals 2 times this quantity divided by 2, so we cancel 2, so we ended up with just pi r squared plus 2 times 2 is 4. Transposing this term to the left, solving for r, so we have 2 square root of 3 r squared minus pi r squared equals 4. Factoring out r squared, so we have r squared times the quantity 2 square root of 3 minus pi equals 4. Solving for r, we have 4 divided by 2 square root of 3 minus pi. Square root of that, or the same way, is equal to 2 divided by square root of 2 times the square root of 3 minus pi. So r is equal to, by using our calculator, and so we have 3.52175. And so r is approximately equal to 3.52 units. Our final answer. And so that's all for now, and for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. Hit that bell so you get notified whenever I upload new videos. Thank you very much. Thank you for watching. Have a great day, everyone. I will see you in the next video. Bye.